Why light refused to follow orders. Light was supposed to be simple. It was meant to move like everything else, fast but obedient. Instead, light broke every rule humans tried to impose on it. No matter who measured it, no matter how fast they moved, light behaved the same way. And that quiet refusal forced physics to confront one of its deepest assumptions. To understand why this still matters today, we have to return to how speed was once understood. Speed felt absolute. Add motion to motion and velocity stack. Walk inside a moving train, and your speed combines with the train's. This logic worked everywhere, except with light. When scientists began measuring light precisely, they expected the same behavior. Move toward the source, and light should appear faster. Move away, and it should slow. But every experiment returned the same result. Light's speed never changed. At first, this seemed impossible. It violated common sense and centuries of intuition. To fix the problem, physicists invented invisible mediums. Hidden backgrounds meant to carry light like air carries sound. But no matter how carefully they searched, nothing appeared. The contradiction grew sharper. Either light was special or the idea of absolute speed was wrong. And the universe offered no compromise. Repeated tests confirmed it again and again. Light obeyed its own rule. This was the moment physics stopped trying to command reality and started listening to it. Because if light refused to follow orders, then the orders themselves were flawed. And that realization would force a complete rewrite of space, time, and motion itself. At first, scientists tried to preserve intuition. They adjusted equations. They added corrections. They searched for hidden errors. Anything to avoid abandoning the idea of absolute motion. But every attempt failed. Light continued to behave with stubborn consistency. This forced an uncomfortable choice. Either experiments were wrong, or the framework used to interpret them was. Slowly, reluctantly, the second option became unavoidable. The universe was not obligated to match expectation. Accepting this meant letting go of a deep assumption, that time and space were fixed backgrounds unaffected by measurement. If light speed was constant, then distances and durations had to change instead. Space would contract. Time would slow, not as illusions, but as physical effects. This was not a minor adjustment. It meant that observers moving relative to each other experienced different realities. Measurements that once felt universal became personal. Lengths depended on motion. Clocks depended on speed. Reality fractured into perspectives. This idea felt radical, even dangerous. It suggested there was no single objective description of events, only consistent ones within each frame of motion. The universe allowed disagreement, as long as the underlying rules held. Experiments confirmed the theory with precision. Fast-moving particles live longer. Atomic clocks drifted apart when accelerated. Nothing broke the pattern. Light remained constant, and everything else adapted. What began as a puzzle about light became a crisis of certainty. The universe was not asking for permission. It was enforcing its rules. And those rules placed light at the center of reality, not as a participant, but as a limit. The conflict reached its peak when physicists realized what this limit truly meant. Light was not just fast. It was unreachable. No matter how much energy was added, nothing with mass could ever catch up to it. Speed itself had a ceiling. This shattered the old idea of unlimited acceleration. Motion could increase, but only up to a boundary that could never be crossed. As objects approached this limit, space compressed ahead of them. Time slowed within them. Energy poured in, but speed refused to comply. This buildup revealed a deeper structure beneath reality. Space and time were not independent. They were intertwined, responding together to motion. Push one too hard, and the other pushed back. The universe enforced balance through geometry, not force. This had profound consequences. Cause and effect were preserved not by intuition, but by the speed of light. Information could not travel faster. Influence had limits. The universe protected consistency by refusing shortcuts. Emotionally, this was difficult to accept. Humans instinctively imagined no bounds. More power, more speed, more reach. Light represented a hard stop, a reminder that the universe sets limits that cannot be negotiated. By this point, Light was no longer just illumination. It was structure. It defined how fast reality could update itself. It governed what could influence what, and it stood as a silent boundary that nothing could cross, no matter how determined. The build-up was complete. One final realization remained. If light set the limit for motion and information, then it also set the framework for existence itself. The climax of this story is a quiet surrender. Light was never meant to follow orders. It was meant to set them. Once this was understood, physics reorganized itself around a new center. Space and time became flexible, shaped by motion. Energy and mass intertwined, and light stood at the boundary, defining what was possible. This insight reshaped technology and theory alike. It governs particle accelerators, satellite communication, and the structure of space-time itself. Every modern system that relies on precision timing or transmission quietly obeys light's rule. More deeply, it reshaped perspective. The universe does not allow infinite speed or instant influence. It enforces patience. Cause must wait for effect. Information must travel. Light ensures that reality unfolds in an orderly sequence. The refusal of light to obey intuition was not defiance. It was guidance, a signal that the universe had deeper rules than common sense allowed. And by listening, humanity gained a clearer map of reality. Light did not break physics. It completed it, and in doing so, it revealed a universe that is limited, consistent, and far stranger than anyone first imagined. So what do you think? Are we repeating the same mistake again?